Hello students, good morning. This side is Vivek Sharma. Welcome to my channel Time Series Forecasting. So in this series we have started with the time series forecasting and we have covered our chapter number 1, which is introduction to the time series forecasting. So now let's move forward to our next chapter, which is moving forward. So before starting that chapter, I would like to highlight some of the key understanding of that previous chapter that we have discussed. So as you already know that first three chapters, introductions, moving average and forecast KPI, they can be served as the basic foundation for the time series forecasting. Rest of them are the advanced concept that we are going to study, like what are the techniques that are usually used in order to predict the future for the time series data. Okay, so let's move forward for the moving average part. Okay, so the first technique that we have, so this can be taken as one of the first basic technique in order to predict the time series forecast. This is basically belongs to the moving average model. That idea is basically based on the future demand is quite similar to the recent demand we have observed. With this model, we simply assume that the forecast is the average demand during the last end period. If you look at the monthly demand, this could be translated as like the June demand will be the average of March, April, and May. So just to clarify the things in the easy word, we can say that in a time series forecasting, if we want to predict demand like at the time of interval t, okay, so demand at dt, okay, will be average of previous end demands that we have, which also means that like if we are taking a value of n, we have to take a value of n something over there, like at the point of t equals t1, t2, t3 and t4, and this is tx. Okay, then demand at t1 is d1, this is t2, this is t3 and this is d4. If we are taking the value of n, which is like how many average value we have to take, then this is denoted by the n. And if n equals to 3 for example, then value at dtx will be nothing else like d2 d2 plus d3 plus d4 divided by 3, because we are taking the n previous demand and taking average of that n previous demand, and in our case n value of n equals to 3. I hope this point is clear. So the one of the basic formula for the moving average is this: 1 upon n divided by the demands that we have in that n period. Okay, so the forecast at the period of t is ft, and n is the number of the periods we have to take average, and demand is demand during that period. If we clarify that point, the forecast at time t will be the average of previous and demands that we have, demand dt minus I, and I varies from 1 to n. I hope this point is clear. Okay, so see, this is a simple graph between this is a simple graph between demand and forecast. Okay, in this case we are taking the value of forecast So basically, this is a graph between demand and forecast, and the value of n seems to be like around n equals to 3. If you really look at the point of the graph, you can see it comes around n equals to 3. That's why the value of the forecast started from the 3 itself. If we have taken the value of uh, n equals to 5, then it should be started from over here. Okay, so basically n equals to 3 or n equals to 5 denotes like how many value we have to take an average in order to predict the future demands. So just to clarify, if we have a number line and we have to predict three demands over here, and this is ft, f1, f2 and f3, and we have the value also present over here, which is d1, d2 and d3. Okay, and suppose the value that we need to take n equals to 3 over here, then the value for the f1 equals to d1 plus d2 plus d3 equals divided by 3 slash, if we take a value of, we need to calculate the value for the focus f2, then it can be calculated like this: d3 plus uh, it should be d2 plus d3 plus f1 divided by 3. Okay, similarly for the f3 that we have, it should be d3 plus f1 plus f2 divided by 3. So these are the some basic formula that need to be understood in order to do time series forecasting. So on the basis of that, we have a similar another model that we have, which is knife forecast. The basic difference between the moving average and the knife forecast is that the value of the n in this model is equals to 1, as you can see, and n is a parameter. Basically it's an parameter that tweaks on the basis like how well we want to define our curve, how the smooth should be the curve it is. Okay, so knife forecast is the simplest forecast. It is always predict the last available for observation. The knife forecast is very interesting as it instantly react to an variation of in the demand, but on the other hand it will also sensitive to the noise and the outliers. Since it is always going to return the previous value itself, then if there is a noise or the outliers present in the data, then it is also read then it is also going to be read in the same manner. So this is the time series, so this is the knife forecast that we have, as well as the moving average. Since there are some limitations also in these in this algorithms, like no trend can be learned by this technique, as well as no seasonality can be captured by these techniques, as well as flat historical weighting. Okay, so let's try to understand all of these points, but before that I just also wanted to discuss one of the point, like what is the significance of the value of the n that provided over here in the moving average part. So if a moving average algorithm where n is a parameter, the value of n also defines something like smoothness of curve. Basically n is directly proportional to the smoothness of curve. For example, if we have a demand like this, like it's started from here, then it's like something like this over here. Okay, and if we are taking the value of n equals to 3, then we can start from something over here, and it is also going to be react in the same manner because it's taken a basically an average. But if we increase the value of n by 3 to 5, you can see there is a smooth curve over here. Okay, so this is a fact that I just wanted to let you guys know because it basically defines the smoothness of the curve. Okay, since in this graph this red line indicates smoothness of curve when the value of n taken as much higher as compared to the knife forecast where value of n is 1 over here. It reacts quickly uh, as compared to other. Okay, as compared to knife forecast over there. Okay, so this is the so the blue line that you are seeing, it's nothing as knife forecast, and the mm, red line that you are seeing, it's a moving average line. The difference is the value of n that we are using over here. Over here the value of n equals to 1, and over here this value can be greater than 1. Okay, so this is the one of the difference. So apart from that, let's go on the limitations part. The model does not see any trend, which also means if there is a upward trend or the downward trend, the model is not able to recognize that trend also over here. As well as no seasonality. If there is a alteration in some periodic changes in the time series forecasting that we can see, it can also not able to capture that, because as you can see, if we increase the value of the n, the smoothness of the curve will increase, and it is not able to capture the seasonality part in that much extent. And the third point is the flat historical weighting. So basically what it is doing, if we take the value of n equals to 3, it is going to take the past 3 values, which is d1, d2, d3, to predict the forecast f1 by dividing the value of 3. Okay, so the issue in this formula is that it is providing a equal weightage to all of the demand that we have, which is 0.332 d1, and which is slightly wrong because the historical historical demand maybe not that much provide a great uh, forecast as compared to that we maybe the forecast is not that much dependent or that much important to the previous one as compared to the new one that we have. So what I mean to say, like f1 can be related much more related to d3 as compared to d1 over here. Okay, so these are the key limitations of this algorithm. And in the forward chapters, since we have started learning about algorithms, we need to analyze how better the algorithms are working. Due to this, we need to discuss some forecast KPIs in our next chapter, like how can we assess examine our models, like whether they are working fine or not, or how can we change the value of the parameters over there, just in case in order to analyze the value of the forecast KPIs that we have. So let's pause our video over here, and thank you everyone for your support and love. If you have any questions, then kindly put in the chats and I will try to answer them as soon as I uh, have a complete explanation as well as the examples for that questions. Okay, thank you so much. Love you.